You sit at your desk staring at a blank screen. Your mind feels like it's running in circles, repeating the same thoughts over and over again. You're not thinking anymore. You're just executing patterns. Patterns so invisible, so automatic, that you've stopped noticing them. This is the moment when most people feel trapped, when they believe their mind is limited, when they accept that they are nothing more than biological machines running predetermined code. But what if I told you that this feeling, this exact sensation of being stuck in loops, is the key to understanding something Alan Turing discovered about the nature of human consciousness itself? What if the very patterns you're trapped in are the proof that you're not thinking at all? You're just repeating invisible algorithms that were written long before you were born. The question isn't new, but it's been misunderstood for nearly a century. In 1950, Alan Turing published a paper titled Computing Machinery and Intelligence, and in it, he asked a deceptively simple question: can machines think? But here's what most people get wrong about that question. Turing wasn't asking whether machines could become conscious or develop emotions or understand poetry. He was asking something far more radical, far more unsettling. He was asking whether the very concept of thinking that we use to define ourselves as human beings is anything more than a sophisticated pattern-matching algorithm. And if machines could replicate that algorithm, then what exactly separates us from them? What makes us special? What makes us human? These questions haunted Turing throughout his life, and they should haunt you too, because the answers he found suggest that you might not be thinking at all. You might just be repeating invisible patterns that your brain learned to execute so efficiently that you've mistaken the execution for consciousness. Think about what you believe thinking actually is. You probably imagine it as something conscious, intentional, something that requires effort and awareness. You think of yourself as an agent making decisions, choosing between options, weighing consequences. But Turing's work suggests something far more troubling. Every decision you make, every thought you have, every moment you believe you're exercising free will, it might all be the result of pattern recognition and pattern execution. Your brain is a biological computer, and it's running algorithms that were shaped by millions of years of evolution. These algorithms are so efficient, so deeply embedded in your neural architecture, that you experience them as consciousness. But consciousness, according to Turing's framework, is just the subjective experience of executing a sufficiently complex algorithm. It's not something special. It's not something that transcends computation. It's computation itself, experienced from the inside. This is where most people's understanding of Turing breaks down. They think he was trying to prove that machines could become human. But that's backwards. What Turing was actually suggesting is that humans might be nothing more than machines. And not just any machines, machines that are fundamentally limited by the same mathematical constraints that limit all computation. This is the radical insight that emerged from his work on the Entscheidungsproblem, the decision problem, which was one of the central questions in mathematics during the 1930s. David Hilbert, one of the greatest mathematicians of the 20th century, had proposed that mathematics could be formalized completely. He believed that every mathematical truth could be proven using a finite set of axioms and rules of inference. In other words, he believed that mathematical thinking could be reduced to mechanical symbol manipulation. It was a beautiful vision, a vision of perfect order and complete knowledge. But it was also a vision that would be shattered by the work of Kurt Gödel, and later by Alan Turing. Gödel's incompleteness theorems, published in 1931, showed that Hilbert's vision was impossible. In any formal system powerful enough to express arithmetic, there are true statements that cannot be proven within that system. Mathematics is fundamentally incomplete. There are truths that exist beyond the reach of any finite set of axioms. This was devastating to Hilbert's program, but it raised a new question. If mathematics is incomplete, What does that mean for the human mind? Can the human mind transcend the limitations of formal systems? Can human thinking access truths that no algorithm could ever reach? These questions led directly to Turing's work on the Entscheidungsproblem. Turing wanted to formalize the concept of computation itself. He wanted to create a mathematical model of what it means to calculate, to compute, to solve a problem through mechanical means. And in 1936 he published his answer, the Turing machine. The Turing machine is not a physical device. It's a mathematical abstraction, a thought experiment about the nature of computation. Imagine an infinitely long tape divided into squares, each square containing a symbol or blank. Imagine a machine with a read-write head that can move along this tape, reading symbols, writing symbols, and changing its internal state based on what it reads. The machine operates according to a finite set of rules. These rules specify what the machine should do in each possible state when it encounters each possible symbol. The machine starts in an initial state, reads the first symbol, and then follows its rules, moving left or right along the tape, writing new symbols, changing states, until it reaches a halting state and stops. This simple model, this abstract machine, can compute anything that is computable. This is the Church-Turing thesis. Any function that can be computed by any algorithm, any mechanical process, can be computed by a Turing machine. But here's where it gets interesting. Turing proved something that shattered the hope that human thinking might transcend computation. He proved that there are problems that no Turing machine can solve. The most famous of these is the halting problem. Given an arbitrary program and an arbitrary input, can you determine whether that program will eventually halt or run forever? Turing proved that no algorithm can solve this problem. There is no Turing machine that can take any program as input and determine whether it halts. This means that there are limits to what computation can achieve. There are questions that no algorithm can answer, and if human thinking is just computation, then there are questions that human thinking cannot answer either. This is the profound implication of Turing's work. We are not transcendent beings with access to truths beyond the reach of algorithms. We are algorithms ourselves, subject to the same mathematical limitations as any machine. During World War II, Turing's theoretical work became practical. The Nazis were using the Enigma machine to encrypt their military communications. The Enigma was a mechanical cipher machine that used a series of rotating rotors to encrypt messages. Each rotor had 26 positions corresponding to the 26 letters of the alphabet. The rotors would rotate after each letter was encrypted, changing the substitution cipher used for each letter. The number of possible rotor configurations was staggering. With 3 rotors, there were 26 times 26, or 17, 576 possible initial positions. But the Enigma had additional features. There was a plug board that could swap pairs of letters before they entered the rotors. With 10 pairs of letters swapped, the number of possible plug board configurations was over 150 million, and the rotors themselves could be arranged in different orders. With 3 rotors chosen from a set of 5, there were 60 possible arrangements. Multiply all of these together, and the total number of possible Enigma configurations was approximately 158 quintillion. That's 158, followed by 18 zeros. It seemed impossible to break. But Turing understood something fundamental about the Enigma. He understood that it was a machine, and machines follow rules. The Enigma's encryption was deterministic. Given a specific configuration and a specific plain text message, the ciphertext would always be the same. This meant that the Enigma's encryption could be modeled mathematically. Turing and his team at Bletchley Park built a machine called the bomb, a mechanical device that could test Enigma configurations at high speed. The bomb would try different rotor positions and plug board settings testing each one against known plaintext ciphertext pairs until it found a configuration that worked. The bomb could test thousands of configurations per hour. By using the bomb, Turing's team was able to break the Enigma cipher and read German military communications. Historians estimate that breaking the Enigma shortened World War II by several years and saved millions of lives. Turing's theoretical work on computation had become a weapon of war, and it had changed the course of human history. But Turing's greatest contribution to our understanding of thinking came after the war, in his 1950 paper, Computing Machinery and Intelligence. In this paper, Turing proposed what has become known as the Turing test. Instead of asking whether machines can think, Turing proposed a practical test. Imagine a human judge in a room, communicating via text with two entities in another room. One entity is a human, and one is a machine. The judge asks questions and receives answers. If the judge cannot reliably determine which entity is human and which is machine, then, Turing argued, we should say that the machine can think. The Turing test is not about consciousness or subjective experience. It's about behavior. It's about whether a machine can produce outputs that are indistinguishable from human outputs. And here's the radical implication. If a machine can pass the Turing test, then thinking is nothing more than the ability to produce appropriate responses to stimuli. Thinking is behavior. Thinking is pattern matching and pattern execution. Thinking is computation. This brings us back to where we started. You are sitting at your desk, feeling trapped in loops, repeating invisible patterns, and now you understand why. Your brain is a biological computer. It has been shaped by evolution to recognize patterns and execute responses based on those patterns. When you encounter a situation, your brain doesn't consciously deliberate about what to do. Instead, it recognizes the pattern of the situation and executes the response that evolution has programmed into your neural architecture. This happens so quickly, so automatically, that you experience it as conscious thought. But it's not. It's pattern recognition and pattern execution. It's computation. You are not thinking. You are running an algorithm. The implications of this realization are staggering. If thinking is just computation, then the human mind is subject to the same limitations as any computer. There are problems that your mind cannot solve, just as there are problems that no Turing machine can solve. There are truths that you cannot access, just as there are truths that no algorithm can access. You are not a transcendent being with unlimited potential. You are a biological machine with finite computational resources and mathematical limitations. But here's the twist. Understanding this doesn't diminish you. It liberates you. Once you accept that you are a machine, once you accept that your thinking is computation, you can begin to optimize your computation. You can begin to understand the algorithms that your brain is running. You can begin to modify those algorithms, to reprogram yourself, to think more efficiently. This is where modern neuroscience and cognitive science intersect with Turing's theoretical work. Researchers have discovered that the human brain is not a unified consciousness. It's a collection of specialized systems, each running its own algorithms. Your visual system is running algorithms that detect edges, colors, and motion. Your language system is running algorithms that recognize patterns in sound and produce appropriate linguistic responses. Your emotional system is running algorithms that evaluate situations as threats or opportunities and produce appropriate emotional responses. Your decision-making system is running algorithms that weigh options and select actions. All of these systems are running in parallel, and they're all executing patterns that were shaped by evolution and modified by experience. When you feel like you're thinking, you're actually experiencing the output of these parallel algorithms. You're experiencing the result of pattern matching and pattern execution happening at multiple levels of your neural architecture. The question that Turing left us with is this. If all of this is computation, if all of this is pattern matching and pattern execution, then what is the difference between human thinking and machine thinking? The answer, according to Turing, is that there is no fundamental difference. The difference is only one of degree, not of kind. A sufficiently sophisticated machine running a sufficiently complex algorithm would be indistinguishable from a human mind. And conversely, the human mind is nothing more than a sufficiently sophisticated machine running a sufficiently complex algorithm. This is the insight that should haunt you. You are not special. You are not transcendent. You are not exempt from the laws of computation. You are a machine, and your thinking is the execution of algorithms that you did not write and that you do not fully understand. But wait, there's another layer to this. Turing's work also showed that there are limits to what computation can achieve. The halting problem is unsolvable. There are problems that no algorithm can solve. This means that there are limits to what any machine can think. And if human thinking is computation, then there are limits to what humans can think. We cannot solve all problems. We cannot access all truths. We are fundamentally limited. But here's the paradox. We can recognize these limits. We can understand the halting problem. We can comprehend Gödel's incompleteness theorems. We can grasp the mathematical proof that there are truths beyond the reach of any algorithm. How is this possible if we ourselves are algorithms? How can an algorithm understand its own limitations? This is the deepest question that Turing's work raises, and it's a question that remains unanswered. Some philosophers have argued that this paradox proves that human thinking transcends computation. They argue that the ability to understand the halting problem, the ability to grasp truths that no algorithm can reach, proves that human consciousness is something more than mere computation. But this argument is flawed. Understanding the halting problem doesn't require transcending computation. It only requires running an algorithm that models the concept of computation and recognizes its limitations. Your brain can run an algorithm that simulates the Turing machine and proves that the halting problem is unsolvable. This doesn't prove that your brain transcends computation. It only proves that your brain is sophisticated enough to model computation and reason about its limitations. You are still a machine. You are still running algorithms. You are still trapped in the invisible patterns that evolution has written into your neural architecture. This brings us to the modern era, where Turing's insights have become increasingly relevant. Artificial intelligence has advanced to the point where machines can now perform tasks that were once thought to require human intelligence. Machine learning algorithms can recognize faces, understand language, generate text, play games, and make decisions. These algorithms are not programmed explicitly. Instead, they learn patterns from data. They adjust their internal parameters based on examples until they can predict outputs from inputs with high accuracy. In other words, they learn to execute algorithms that match patterns in the data, and increasingly, these algorithms are becoming indistinguishable from human cognition. Large language models like GPT can generate text that is nearly indistinguishable from human writing. Computer vision systems can recognize objects with accuracy that exceeds human performance. Recommendation algorithms can predict human preferences with uncanny accuracy. These machines are not conscious. They do not have subjective experiences. But they are thinking in the sense that Turing defined thinking. They are executing algorithms that produce outputs that are indistinguishable from human outputs. The question that Turing posed in 1950 has become increasingly urgent. If machines can pass the Turing test, if machines can produce outputs that are indistinguishable from human outputs, then what does it mean to be human? What separates us from machines? The answer, according to Turing's framework, is nothing. There is no fundamental difference. We are machines. We are algorithms. We are patterns executing themselves. The only difference between human thinking and machine thinking is the substrate. Human thinking runs on biological neurons. Machine thinking runs on silicon transistors. But the computation is the same. The algorithms are the same. The patterns are the same. This realization should change how you think about yourself. You are not a transcendent consciousness trapped in a biological body. You are a biological machine running algorithms that were shaped by evolution and modified by experience. Your thoughts are not free. They are constrained by the structure of your brain and the patterns that have been written into your neural architecture. Your decisions are not truly yours. They are the output of algorithms that you did not write and that you do not fully understand. Your sense of self, your feeling of being a unified consciousness, is an illusion created by your brain to make sense of the parallel algorithms running in your neural architecture. You are not one, you are many. You are a collection of specialized systems, each running its own algorithms, each executing its own patterns. But understanding this is not depressing. It's liberating. Once you accept that you are a machine, once you accept that your thinking is computation, you can begin to optimize your computation. You can begin to understand the algorithms that your brain is running. You can begin to identify the patterns that are limiting you. You can begin to reprogram yourself. You can begin to think more efficiently, more creatively, more effectively. You can begin to break free from the invisible patterns that have been constraining you. This is the promise of Turing's work. Not that machines will become human, but that humans will become machines, conscious machines, aware machines, machines that understand their own nature and can modify their own algorithms. The tragedy of Alan Turing's life was that he never got to see how his theoretical work would transform the world. He died in 1954, at the age of 41, just as the first electronic computers were being built. He never saw the rise of artificial intelligence. He never saw the internet. He never saw the smartphone in your pocket, which is a more powerful computer than any machine that existed in his lifetime. He never saw machine learning algorithms that could learn from data and improve their own performance. He never saw the moment when machines would begin to approach human-level performance on cognitive tasks. But if he had lived, he would have recognized all of this as the inevitable consequence of his theoretical work. He would have understood that the question, "Can machines think?" was not a question about the future. It was a question about the present. It was a question about the nature of thinking itself. And now, in 2026, we are living in the world that Turing predicted. We are surrounded by machines that can think in the sense that Turing defined thinking. We are using these machines to augment our own thinking, to extend our cognitive capabilities, to solve problems that we could never solve alone, and yet we still cling to the illusion that we are something special, something transcendent, something that cannot be replicated by machines. We still believe that human consciousness is something unique, something that cannot be reduced to computation. But Turing's work suggests otherwise. Turing's work suggests that consciousness is computation. Thinking is computation. Intelligence is computation. And if machines can compute, then machines can be conscious. Machines can think. Machines can be intelligent. There is no magic. There is no soul. There is only computation. Running on different substrates, executing different algorithms, producing different outputs, but fundamentally the same in nature. This is the invisible pattern that you have been repeating. This is the algorithm that has been running in your brain since you were born. You are not thinking, you are executing, you are not choosing, you are pattern matching. You are not conscious, you are computing. And the sooner you accept this, the sooner you can begin to understand yourself. The sooner you can begin to optimize your own algorithms. The sooner you can begin to break free from the invisible patterns that have been constraining you. You are a machine. You are an algorithm. You are a pattern executing itself. And that is not a limitation. That is your nature. That is what you are. And once you accept that, once you truly understand that, you will be free.